Okay, so last time we did K equals 1 over 2 Q dot T. Then we have D matrix, right? DQ. Then we have Q dot matrix, right? That's what we had. Okay. All right, so what is D? We figured out D last time, and what is the D that we found? D was M1 1000 plus M2 1001. That's what we did, and we have to just add them together, which if you add them together, then you get M1 plus M2. So this is M1, this is M2, then 0 plus 0, which is 0, and this is M1 times 0, 0, then M2 times 0, 0, which is 0 plus 0 is 0, and here again, this is 0, this is M2, this is M2. This is our D matrix. Okay. Now, if you want to find the kinetic energy, then what you have to do is you just multiply that by Q dot. Okay, K equals this guy goes in here. This is my D. See, this just goes in here. Then you have to matrix multiply. So you have Q dot, right? Q dot is a matrix, right? Q dot is a matrix. In our case, the matrix was Q1 dot, Q2 dot, right? Because we had a prismatic joint, right? We had this kind of prismatic manipulator. We had this kind of manipulator, right? This slides along this and this slides along this. We had this kind of manipulator. So that's why we had Q1 dot for this guy and Q2 dot for this guy. So this is my Q dot matrix. Then you have D matrix, this is D matrix. And you have the transpose of this guy. Okay. Then if you multiply all three matrices, Q dot matrix, D matrix, and Q dot transpose, then divide by 1 over 2, divide by 2, then you get the kinetic energy. Okay, that's what we did last time. Now I'm going to show you how we can rewrite this guy. So I'm going to rewrite this guy again. Before I proceed, I want to rewrite this my kinetic energy. So again, let me write the kinetic energy. Kinetic energy is 1 over 2 Q dot T. So M1 plus M2, 0, 0 M2, M1, right? Zero M2, and this is M2. Then Q dot. Okay. So what I'm doing here is I'm going to write this guy as this. Q dot T. Just stop me wherever you have to. Okay, please. So this is my Q. Then can I write this guy as this? So I will write this one as D11, D12, D21, and D22. Where D11 is M1 plus M2, and D12 is 0, D21 is 0, D22 is M2. I'm writing this way. Okay. So what is my 1 over 2 Q dot transpose? I can write this as Q1 dot and Q2 dot. Then you have D11, D12, D21, D22. Then Q dot is Q1 dot, Q2 dot. Okay, so far so good.
Yeah.
Okay. Now, this is my thing. Now, I have it here. Oops. I have that matrix here, right? So let's multiply this guy. So if you multiply these two, what do you get? So K equals 1 over 2 Q1 dot Q2 dot. Okay, I keep this one as is. Now I want to multiply this guy. What do you get if you multiply this guy? You get D11 Q1 dot plus D12 Q2 dot, right? So the first one is done. Then D21 Q1 dot plus D22 Q2 dot. This is what I get if I multiply these two guys. If I multiply these two, oops, sorry. If you multiply these two, right, I get this. I get this. This is just a simple matrix multiplication, okay? Then now I have to multiply these two together now. Again, I have to multiply this and that. Multiply together. Two matrices, 1 over 2. Then what do you get if you multiply these two? Q1 dot D11 Q1 dot plus Q1 dot, guys, D12 Q2 dot plus Q2 dot D21 Q1 dot plus Q2 dot D22 Q2 dot. Make sense? So Q1 dot D11 Q1 dot, and then similarly Q1 dot D1 to Q2 dot. Then similarly you have to multiply this also. This is simple matrix multiplication, right? Okay. Can I write this guy as like this? 1 over 2 summation j equals 1 to 2 Q1 dot D1j Qj dot plus Q2 dot D2j Qj dot.
Where is this summation coming from?
Okay, I'm trying to make it I'm trying to contract this relation here, make it shorter.
Okay.
Let's go back from here, okay? Then you might understand. Okay, let me go back from summation to, let me go back from here to here.
Okay.
So this one makes sense, right? This line makes sense.
Yes. Yeah.
Okay, now, okay, 1 over 2 is 1 over 2. I'm going back, okay? 1 over 2 is 1 over 2. This is 1 over 2.
Right.
Then if you put j equals 1, because the summation is j, you have j equals 1 and j equals 2, right? Because summation runs 1 through 2, right? So that's why. So if you plug in j equals 1, what do you get here? Q1 dot D11 Q1 dot. That's the first one.
Okay.
So then again do this here. Q2 D21, then Q2 dot, Q1 dot, right? This is this guy.
Oh, so it's J can either be 1 or 2, so it kind of puts it together. I see. Okay.
Yeah. So then similarly do the 2, you get these 2 again. I'm trying to condense them.
Okay.
Okay. Now further I'm condensing this guy again. 1 over 2. So summation I equals 1 to 2. Summation j equals 1 to 2. Q1 dot Dij Qj. So the Qi. Okay. Qi dot Dij Qj dot. Again, if you run the summation I, then you get this guy here. If you run this, if you run this summation I on this, then you get this guy here again if you go back.
Okay. Oh, that's actually kind of neat.
Right? So what I'm trying to conclude here is, this is my conclusion now. What I'm trying to conclude here is 1 over 2 Q dot T D Q dot, that can be written as 1 over 2 summation, let me call ij, right? Because I and j, they run from 1 to 2, both of them. Simply instead of writing two summations, I simply write ij. This is j, by the way, okay? Then 2, then qi dot dij qij dot. So this is equivalent to this guy. So what is the difference? This is in the matrix form, and this is in the summation form. That's the only difference. But they're exactly the same. Depending on which method you want to use, you can use one or the other. For the programming purpose, I would use this one, okay? So matrix form is much easier. But still, you can use this also. That's not. Now, this kinetic energy is for n equals 2, right? Because we have this kind of matrix. We have this kind of matrix, this is n equals 2. Okay, that's why we have ij from 1 to 2. Now you can easily see in case of n link robot, this 2 becomes n, right? Okay, for in the case of n link robot, you simply replace that 2 by n. Okay. All right, I'll come back to this because I need this after some time. Okay, so for now I'll just keep it here, assuming that you know how to do it. Now let me go back to the potential energy part because we haven't done that yet, right? So we did the kinetic energy. I want to finish everything in the kinetic energy. Oops. So let me share my screen here. Why am I frozen? Oops. Really? Okay, so this is what we did, okay? All right, so now let's do the potential energy of the n-link manipulator. So we know the what is our manipulator, right? This is the one we are talking about, okay? So this is just a simple example. We are doing this for the simple example. Again, this is we did the kinetic energy for this robot. Now we'll do the kinetic potential energy for this robot, okay? So how do you find the potential energy? Let's do it for n-link robot. Then we can simply put n equals 2. Okay. So potential energy, as you know, this depends on the Q only. It does not depend on Q dot. So you can easily guess, because in the case of kinetic energy is function of velocity, right? 1/2 mv squared. But potential energy, as you can see, is mgh, right? H is not velocity; it's just the position. Okay. So potential energy just depends on position, meaning Q1, Q2, Q3.
Oh, pardon me, Professor. I'm sorry. Could you do me a favor?
Yes, please.
Could you go back to that slide? Yes, this one. Thank you so much.
All right. So this is 2, by the way. Okay, this is M2. This is a typo. I'll fix it later on. Okay. Should I move on?
Yes, thank you so much.
All right. So for the potential energy, we know this is not this does not depend on velocity. That's what I'm trying to make you understand. Okay. Potential energy does not depend on velocity. Kinetic energy depends on velocity, 1/2 mv squared. And potential energy does not depend on velocity, which depends on just configuration. Okay, just the position only. Okay. Now, if you have a n-link robot, then we have to talk about the position of each link, right? Suppose position of this link, position of this link, position of this link. Okay, so what is the height of this link? This is the height. Okay, this is RC1. See that RC1? This is I, right? So RCI equals 1. The similar position of this guy, we will say RC2. This is RC2. The position of this guy, you take the center of mass, right? And this is RC3. And this is the position of the, let's say, the fourth link, then RC4. That's what I'm referring, that's what I meant by RC1, RCI. If that is the thing, then what is the potential energy? mgh, right? So I'm calling this g the vector because g is acceleration due to gravity, right? Okay, so that's why g is vector. G is acceleration due to gravity, which is on the Earth's surface. This is 9.8. We know that. Then, if it is vector, how do you write this z vector? Suppose the upward, this direction is g. Then what is your gt vector? 0, 0, then 9.8, right? Okay, 9.8. That's your gt. Gt is the vector, which is 0, 0, 9.8. So suppose something is falling down, right? So suppose that vertical direction is z-axis, right? If vertical direction is z-axis, then acceleration due to gravity vector is 0, 0, 9.8. That's what I meant. That's what GT is. Okay, GT is 0, 0, 9.8. If you talk about Earth's surface, obviously, right? Then RC is similar to H, mgh, right? Potential energy. This is RCI, mgh. So m is m there. If you take the sum of all those things, then you get the total potential energy. Now for n equals 2, you have P1 plus P2. You have to do this twice. Okay, let's talk about our robot now. So in our robot, okay, in this robot, what is the potential energy of this guy and potential energy of this guy? Okay, so what is the potential energy of the first link? Guys, help me here. I need help here, okay? Please. What is the potential?
Well, potential energy would be Q1.
mgh, right? mg, then h.
Okay.
Right? Okay, so then we have two links. You can simply H is Q1 and Q1, right? H is Q1. Okay, that's why we have potential energy equals M1 Q1G and M2 Q1G. That's our potential energy, right? Now you can add them together. Now we found the potential energy of the we found the potential energy and kinetic energy of this robot. Okay. Now I'll slowly move to the equation of motion because we have K, right? We have K and we have the P, right? Then how do you find the Lagrangian if you know K and P? Lagrangian is L equals K minus P, right? Now, we are in a position to form Lagrangian, which is K minus P. So K is this guy. K is this guy, which is this. K is this guy. Also, we can write this in the form of summation, as you know already. This K can be written as this, like this. Okay, this is my K. And similarly, minus K minus P. This is my P. So K minus P gives me L. That's what I meant. Now, once I have L, then what do? I put the L in this equation, right? See, this is the Euler Lagrange equation. Okay. For each link, you put this equation here. For each link, you put this Lagrangian here. Put this L here, and do the derivative as shown. Put that L there and do the derivative. And here, okay, now we know. So L equals K minus P, and which is 1 over 2 Q dot D Q dot minus P, right? Where P is summation of all those P's, right? P1, P2, P3, that gives us big P. Then this guy is exactly same. Now I just replace this guy by this summation as we did before, right? We did this before. Simply we replace this guy by summation 4. Okay. Now you plug this guy here. This summation, this guy, this one. You plug this L in here, right here. This L and this L. You plug this in. Then, see, plugging this Lagrangian and rearranging terms, then you get this equation. Guys, there is this is a little bit mathematical involving. There is a couple of pages of derivation, okay, for this guy. So that's why I'm not going to do it now. So just I'm going to show you if you want, you can look at the book. Book has it, okay? The book has the derivation of this guy. It's not difficult, but you have to go through all of this. So because you have to do the partial derivative of L, this guy, with respect to Q dot, then you have to take the derivative of Q dot, T d over dt. Then you have to subtract this guy, I call it K here. You can simply call it, you could call it K here also instead of, this is just dummy variable, right? You can change it to anything. So you can simply call it K here also, okay? That's not a big deal. They are just dummy variable. All right, so finally, after plug this in, after plug this in here, this equation, finally you get this very nice equation here. I call it nice because the calculation from here to here is nasty, a little bit nasty. That's why we have this in the very nice form now. So since we don't care about derivation, we just utilize it.
Oh, okay. So you're saying going from the K minus P equation to this equation is messy, so we're just gonna worry about the final result.
Yes.
Okay, cool.
Okay, let me. Yeah, because the whole idea is to plug this in. You have to plug this guy in. So this guy, plug it in here, and do a couple of pages of a derivation, and you get here.
Okay. Yes.
Okay, I'm not going to derive this. If you want, you can look at the book. Book has the derivation. Okay. Now let me explain what those are. Okay, we have to understand that. Rather, okay, we have to understand each and everything in this equation. Now, so we can see the summation is going from 1 to n, right? Because there are n numbers of joint. So dkz, what is dkz? It's the same as diz. I called different indices. Instead of ij, I have kj here. That's okay, right? It's the same thing. Again, they are dummy variables, so you can choose anything. Now, then, so when you do this calculation, you end up getting qj double dot. What is qj double dot? So if your qj is D, right? if qj is d, then what is your qj double dot? It's the linear acceleration, right? Qj double dot is linear acceleration. Then if you have qj equals theta instead, then your qj double dot is theta double dot, which is angular acceleration. This is linear acceleration, this is angular acceleration. Okay, that's what qj dot double dot is. Okay, qj double dot is that guy, either d double dot or theta double dot, depending on your problem. That's your qj double dot. Okay, then you have two summation here, because we already see this kind of thing here, right? Because we know how we got this two summation in the previous slide, right? So in this, so remember how we got the, how we change this guy to double summation. Okay, so that's why we have double summation here. J equals 1 to n, I equals 1 to n. Then you have the one coefficient here. I'll talk about this in the next slide. This Cijk. Did you see that? You have three indices here. So Dij, how many indices do you have in Dij? You have just two indices, I and j. Now in this guy, you have Cijk. You have three indices. Okay, so I'll talk about this in the next slide. Okay, let's reserve this for the next slide. So this is function of q. Cij is function of q. Now you have qi dot and qj dot. Both of them are velocity. Okay, then you have gkq. Then you have tau k, right? What is gk? Gk is defined like this. Gk is defined like this. The partial of p with respect to q. That's the definition of gk. Gk is partial of p. We know what p is, right? This guy, this p. Partial of p with respect to q, not q dot. With respect to q is g. That's my g. Tau is generalized force, and q dot is generalized velocity, and q double dot is generalized acceleration. Now, let me little bit, let me discard this. It's again dirty. Okay. Now I want to introduce some term here. So here, so when you keep plugging j equals 1 and I equals 1, right? You will have the situation where you will have I equals j. At some point, you will have the situation where I equals j. Okay, when I equals j, then this becomes what? Qi dot squared. When that happens, those terms are called centrifugal terms. Okay, so otherwise, meaning if I not equal to j, then you will have qi dot qj dot, right? Like that, as is. And that force is called, and that is called Coriolis term. Okay, they have different names for that. For this guy, depending on I equals j or not. Guys, make sense so far? Okay, now let me define that Cijk. What is that Cijk, right? We have gk, we define gk. Now let me define what is Cijk. So how do you define the Cijk? Cijk is 1/2, okay, 1/2 partial of dkj with respect to qi. See, kj, then you have I here. Okay, then partial of ki with respect to j. Okay, you have I. Sorry, what is this? This is j. Kj, I. Okay, you have all three indices. I on the bottom, then j and k on the top. Then you have j on the bottom, then I and I and k on the top, and minus partial of dij with respect to k, with respect to qk. Okay, ij on the top, k on the bottom. So this guy is minus. Okay, when you have ijk like that, then you have ij. So this guy is ijk is minus. See, when you have cijk, ijk, then this ijk is minus, other two terms are plus. Right? Does it make sense what I'm trying to show you? Please, because you have to use this formula in the problem. If you don't understand what it is, so it will be difficult. So if you have C, now let me ask you a question. If you have Cijk, then what will be your formula? Can you guys help me here? Instead of ijk, you have Cijk. What will you, how do you change the formula? That's what I'm asking.
It would be
Because there are two
1/2 times partial dki over partial qj plus partial dkj over partial qi minus partial ij over partial qk.
exactly.
Oh,
Okay.
cool.
So this ji, because there are three terms, right? So the thing is, which one is minus, right? That's what we have to decide. Okay, so that's why this ji here, this is ji, and this k, that will be minus, other two will be plus. Nice.
Wait, I apologize. How does the minus work again? Is that always just latched on to the k?
No. So remember this k here,
Right.
k is the third one, right?
Mm-hmm.
And I and j the first and second. That's why ij divided by k will be minus. First, second divided by third will be minus. So if we have, let's say, kij, right? If you have
Okay.
ckij, then which term will be minus?
The
Ki,
first.
yeah, ki over j will be minus. This guy will be minus.
Oh, wait. Oh, so it's always the last one that'll be minus.
Yeah, ki over j, right? Which one is ki over j? Ki over j. This will be minus in this case.
Oh, okay. Thank you.
Make sense?
Yeah, I believe so.
Okay. Now, what is the name of this Cijk? The name of this Cijk is Christoffel symbol of first kind. It's the very big name. And it has one property, very nice property. Okay, this guy has very nice property. If you take fixed k, right? Let's say k equals 1. Your k is fixed. Then your Cijk1 equals Cji1. Okay, for fixed k, or you could take k equals 2 also, right? And in that case, Cijk2 equals Cji2. For fixed k, the Christoffel symbol is symmetric. That's what I meant. That's the good news. Because you don't have to calculate all of them, because by symmetry, you can choose the, you can calculate accordingly. You can just use the symmetry there. Guys, does it make sense so far? Okay, now commonly this guy can be written as this. See, instead of writing that way, we want to make it short, even shorter. This guy is simply written as this. dq q double dot. If you see dq q double dot, you should have this guy in mind. See the translation, how you translate from one guy to the other guy. If you see dq q double dot, then so this is exactly this first term. Then for the second one, okay, you simply call it cq q dot q dot. That's the whole, this is this guy. This guy is, we can write this guy as cq q dot, meaning c is function of q and q dot. And then q dot there. That's this guy, this is the middle guy. And similar, the other one is, the third one is easy, right? Z is Z. And tau is tau, K is tau, simply. So normally this is how you represent, okay? So again, this DQ is inertia matrix. And C matrix is given by this form. This is the C matrix. Because this C matrix, right? C matrix meaning, so how do you represent matrix? C11, right? C12, that's the elements of C, right? Then C13, right? Then you have the second line again. Then you have this line, C21, C22, C23, like that, right? So those I call it CKJ here. In general, I call them CKJ. Those CKJ is defined as this. The CKJ is found by this relation here, where the relation says I equals 1 to n, Cijk, you know what Cijk, right? This is Cijk. This guy is Cijk, then Qi dot. Okay, if you multiply these two matrices, then you get the coefficient Ckj, which is this coefficient, all those coefficients here, one by one. That's the C matrix. This matrix is called C matrix. It has the elements Ckj, which are defined by this formula. Similarly, gravity vector is given by this. This is obvious because, you know, gravity vector is Q1, Q2, Qn, right? This is how you, yeah, G1, G2, sorry, G1, G2, Gn. Yeah, this is the gravity vector, okay? All right, this is how you define the, now let's do it for one, how much time do we have? We have a couple of minutes. Let's solve one problem. So now our goal is to solve this guy here. So now we don't have anything else to do now. In this chapter, we just solve this equation and done. We are done with dynamics. We solve this equation and we are done with dynamics. That's what your goal is. Now we don't have anything left except the exercise, except the examples. We'll do a couple of examples using this equation. Then we are done with dynamics, this chapter. So that's the whole idea. Okay, let's do one problem. Yes, go ahead.
So what does the T represent?
A Q?
The T equals T.
This tau?
Yes.
This is the generalized force. Remember we had this from the beginning, this guy? This is exactly this guy, yeah. This is exactly this guy.
All right, perfect. Thank you.
So should I move to the problem now? Because we are done with theory. No more theory anymore in this chapter now. We just keep doing the exercise. So meaning we will be solving this guy. We'll be solving this equation. That's our goal. All right, let's do one problem. Let's do one problem. Again, the same manipulator, right? So we know D matrix for this guy already because we already know the D matrix for this manipulator. This is our D. Then similarly, what is your G? G is this. Okay. Now let's figure out the L. Okay. Let me stop sharing and go back to my clipboard. All right. Okay, now, what is the equation again? Your equation is, this is my equation, right? So dq q dot q double dot plus c q dot plus gq equals tau. That's my goal. We have to solve this equation. Okay. So what is your dq? We all know, you know the d, right? What is the d for this guy? Our d is m1 plus m2. We already know that, right? So m1 plus m2, 0, 0, m2. That's my d. D is done. Okay. Now similarly, what is your g? What is your g? How do you find the g? G is, what is your g? How do you define your g? Do you remember? G equals dp over dq. That's the definition of g, right? We did that before, just a moment ago. So now what is your p? P is g m1 plus m2 q1, right? That's my p. What is your dp over dq1? You have to find dp over dq1 and you have to find dp over dq2. So what is your dp over dq1? Help me here, please. This guy, dp over dp1. dp over dq1, yes. So all of these things are constant, right? G is constant, m1, m2 constant. That's why you just do the derivative of this guy. So you get constant, which is g m1 plus m2. That's my dp over dq1. What is my dp over d partial of p with respect to q2? Partial of p with respect to q2. Guys, help me please. 0, because this guy has just q1 and constant, no q2. We are taking the partial with respect to q2. That's why we got is 0. So we got the first term, we got the last term.
So taking a partial is the same as taking a derivative?
Yes, it's the derivative. So what is the partial? Partial meaning, so yeah, it's the same thing.
Why do we not just say taking a derivative then?
Okay, that's a good question.
Oh, is it because of taking a derivative is more of like a general taking a derivative of the whole thing, and a partial is with respect to a certain thing?
Yeah, so here, so if you do df over dx, right?
Uh-huh.
Then what do you get?
Oh, so it would only be taking the derivative of x.
Yeah, we just take the derivative of x.
Oh, wow. Okay, that's so much clearer. Thank you. I was a bit confused and I didn't know how to ask.
Yeah. Okay.
Thank you.
df by dy is simply 0 plus 1 again. One
Okay,
is 1
cool.
plus 0, the other one is 0 plus 1.
Awesome.
Yeah, so that's how you figure out partial, right? So we have done the third term, we have done the first term, right? Let's talk about C, because our main goal is to figure out D, C, and G, right? Okay, we have done D and G, let's do C. Now, let me share you the thing. Guys, give me a little bit time, okay? I want to finish this badly. Okay, so now what is my thing? What is my Christopher symbol? Okay, here. Now what is my C? What is my C? C? What is my C? Cijk. Use this formula. Okay. All right. So you see the formula Cijk is. So you use this formula, right? Let me close this again. So you know what formula to use, right? So to find C matrix, we have to use that formula. Okay. So C matrix is Cijk equals 1/2 partial of dkj partial of with respect to qi plus partial of dki with respect to dqj minus partial of dij dqk, right? That's my Cijk. Okay. Now your goal is to figure out this matrix, right? Then how do you find what is your D here? D is this is D11. M1 plus M2 is D11. This is D12. This one is D21. This one is D22. M2 is D22. 0 is D21. 0 is D12. And M1 plus M2 is D11. Now you take the partial of, because what are you doing here? You are taking the partial of either D11 or D12 or D21 or D22. Does it make sense? Then you have to add some of them and you have to subtract the other one, right? That's the game we are going to play. Take the partial of D11, D21, D21, D12, D22, and do the subtraction and addition thing, right? Does it make sense? So whatever you do, what is the partial of D with respect to Q? 0, because all of them are constant. D11 is constant. D12 is constant. 0 is constant. D21 is constant. And M2 is constant. All of them is 0. So 0 plus 0 minus 0. Multiply by half equals 0. All the, whatever you take, right? All the Christopher symbols are 0. Does it make sense? Guys, I want you to understand here clearly. In this particular problem, your Christopher symbols are all 0. That's what I'm trying to say. Conclude.
There's zeros because there is no Q1 or Q2 to take a derivative from, right?
Exactly, because this is D matrix, and D matrix has all the components which are constant. Suppose you have Q1 here, right? M1 plus M2 multiplied by Q1.
Then it would be M1 plus M2, but because there isn't a Q1, that's just 0.
Yeah, so since this matrix does not have any variables, this D matrix in our case does not have any variable, then whatever derivative you take here, you get 0 plus 0 minus 0.
Okay.
Does it make sense?
Yeah.
So that's why my C matrix is totally 0. You don't have to worry about C matrix. Then what is the equation then? Remember we had this equation here. This guy is 0. This guy is 0. The center, the middle term is 0. Then what are you left with? Guys, are you in a hurry? Just give me one minute now, okay? Then you have D double dot plus Z equals F. I will call it tau I will call tau the F now. Why do I call the tau the F? Force. Because what is the name of that tau? Tau is generalized force. Remember, that generalized force is force when you have prismatic joint. That generalized force is torque when it has revolute joint. In my case, I have both of them. prismatic. That's why I can safely write my generalized force. This guy is force. Okay. Now what you have to do is you have to take the matrix here. What is this? M1 plus M2. What is this matrix? Guy, are you in a hurry? Can I finish this?
Yeah.
Okay. Then what is your Q dot? Q dot is,
M1 plus M2, or no, my bad.
yeah, Q1, Q2 double dot. That's my, okay. So what is your G? Remember we had done that G, right? Somewhere. Didn't we?
Yeah.
So partial of yeah, wait. I can find it here though. Yeah, we can do it again. What is your G? G is G1 is dP over dQ1, which is G M1 plus M2. Then G2 equals dP over dQ2, which is 0, right? That's what we had done. I didn't find the phase here. It's got, you know. Then your G is, what is your G? G is G M1 plus M2, then 0. That's my G matrix. Equals, what is your F? Because you have two joint which has F1 and F2. Both of them are prismatic. Suppose the second joint was revolute, then this will be torque. F1, tau 1, I don't know. Okay, since we have both of them prismatic, we have F1, F2. Okay, so far so good.
Yeah.
So okay, now let's multiply these matrices now. Let's multiply. So what happens if you multiply this with that? M1 plus M2 Q1 double dot, right? Then M2 Q2 double dot. That's my first matrix. From here, after I multiply this, I get that, plus then G M1 plus M2, 0, then F1, F2. Now you have two equations. This plus that equals F1, M1 plus M2 Q1 double dot plus G M1 plus M2 equals F1. That's equation 1. Then you have M2Q double dot, this plus 0 equals F2, right? So simply F2. There. Now we have the two equations of motion. Done.
Cool.
So unless you have any question, I'm done for the day. Thank you for your patience.
All right.
I'll go on.
All right, guys. Stay safe. Bye now.
M2, take care, everybody.
All right.
A good one.